Hi folks, we're going to take a look at the solution to page 158, number 22. Okay, so here's the problem here. They tell us that the printed area of a page is going to be 81 centimeters squared, and then they give us some information about the margins, and in fact they even provide the diagram for us. So the margins are 3 centimeters above and below and 2 centimeters to the left and right, and they want to know what page dimensions will minimize the amount of paper needed. Okay, so let's start by setting up our diagram, which I've actually started here. Okay, so this is just what they've set up for us, and they've told us that this area is equal to 81 centimeters squared, which is just the printed portion. It doesn't include the margins. Okay, so what we need to minimize is the amount of paper used, so the area of the whole. So we'll call this area printed, and here we'll call what I'm trying to minimize the total area. Okay, and of course area is length times width for a rectangle, so LW, and we have the usual problem that we've got two variables here, so we need to write in terms of one. Now what I have information about is the area of the printed part. Okay, so I'm going to give dimensions to this rectangle here. Let's say I call this X and I call this Y. So first of all, I can write the length of the paper as X plus 2 plus 2, so X plus 4. Okay, and the width can be Y plus 3 plus 3, so Y plus 6. So I can rewrite this as X plus 4 times Y plus 6. Still two variables, but why did I do that? Because the constraint that they give me doesn't have to do with this larger rectangle, but with this smaller one. Okay, and now I know that the area, which is 81, by the way, everything's in centimeters squared, so I don't have to worry about changing units, okay, is going to be equal to X times Y, the area of the smaller one. And so now I can pick one of the variables to solve for. I'll pick Y, so 81 over X, and now I can input this into my equation. So I have X plus 4 times 81 over X plus 6, and there we go. We have now an expression in terms of one variable, and clearly here X has to be greater than 0 since it's a measure of length. So in order to take the derivative, I don't think I need to use the product rule, because it's going to be much easier if I just multiply everything out. Okay, so X times 81 over X, the X's cancel out, so just 81 plus X times 6, so 6X, plus, so here 4 times 81, so that's 320 plus 4, so 324 over X, and then 4 times 6 is 24. I'm not even going to bother adding these together, because I know that when I take the derivative, okay, which is what I need to do, they're both going to disappear because it's derivatives of constants. Okay, so here derivative of 6x is just 6, and then here this is 324 times x to the minus 1, so the negative 1 will come down, so minus 324 times x to the negative 2, so over x squared. And you need to make this equal to 0, and a fairly easy equation to solve. So multiply both sides by the lowest common denominator, so I've got 6x squared minus 324 equals 0. So 6x squared equals 324, and so x is just equal to the positive square root, since x is a measure of length, of 324 over 6. Okay, so here let's get an estimate for that. So we have the square root of 324 divided by 6 gives us about 7.4. Okay, now we need to test that this is indeed I guess here minimum is what we're looking for. So here we know we're only interested in greater than 0, so 7.4. So let's use this expression for the derivative. So I don't know, let's stick x equals 1. So we have 6 minus 324 divided by 1, not surprisingly, is negative. And let's pick, I don't know, 10. So we have 6 minus 324 divided by 10 squared, which is 100. And so there we go. We've got something that is positive. Okay. Now, because from 0 onwards, that's the only place the derivative can change sign, we know that it's continually decreasing till 7.4 and then continually increasing after that. So it is indeed an absolute min. Okay, so now that I have my values, let's go back to the question. It says, what page dimensions will minimize the amount of paper? Okay, so I need the page dimensions, so I need L and W. So when I go for my answer, I have to make sure I'm finding the right thing. Okay, so here we have L is equal to x plus 4, so 7.4 plus 4, so that's 11.4 centimeters. Okay, and then W is y plus 6, but remember y was just 81 over x, so 81 over 7.4 plus 6, and that will get our trusty calculator. So here we've got 81 divided by 7.4 plus 6, and so here we've got about 16.9 centimeters. Okay, let me check that one again. 81 divided by 7.4 plus 6. Yeah, that looks good. Okay, so there we have it. So let's just recap. We're trying to minimize the area of this paper here, okay? But the constraint they give us has to do with the printed area, which is a smaller rectangle, which is why I chose to work with variables x and y, representing length and width of the smaller rectangle instead of going via the length and width of larger ones. Okay, that's it for this one.